Good morning, everybody. Welcome to today's webinar on the topic of sustainability in the bioeconomy. My name is James Ling. I'll be moderating today's webinar. Excuse me for my haircut. This can't go to the hairdressers these days as we're all stuck at home. Anyway, I'm Communication Project Manager at Greenovate Europe. Greenovate Europe is a network of sustainable innovation experts who together provide services to accelerate the green transition. I invite you to find out more about our work at greenovate-europe.eu. Before we get started, I just will run you through the technical details. This webinar is being recorded. The recording and the PowerPoint presentations will be shared shortly after the webinar. You are all in listen-only mode, but we very much welcome your questions, which you can send in through the question box. Speakers will answer a couple of questions at the end of each presentation. We also have time set aside at the end of the webinar for a discussion period. As you can imagine, all of our speakers are at home today, so please forgive us for any crying babies, barking dogs, disorderly neighbours, etc. So, just to explain a bit the context of today's session, this webinar has been organised in the framework of the Bio for Products project. Bio for Products has been funded by the SPIRE public-private partnership under the EU Horizon 2020 programme. The project is an innovation action demonstrating how to transform 4 types of biomass into 4 different bio-based products, using fast pyrolysis as the conversion technology. At the bottom of your screen, you can see the project partners. We are coordinated very ably by BTG Biomass Technology Group from the Netherlands. So this webinar today is part of a series that we've been organising. One of the main ways that we want to share the results of the project and discuss a bit with external partners. Previous webinars have focused on the topics of biomass feedstock, conversion by fast pyrolysis, and product development. I invite you, if you were not in attendance, to catch up on those webinars via our YouTube channel. So for today's webinar, to round off the series, we wanted to sort of take a step back, ask, actually, how sustainable is all of this? How do we measure it? And how should we communicate about these new products? So, to try and get some answers, we've recruited 4 wonderful speakers. Here they are. You can see them there. So, Jurjen Spekreijse is a colleague of mine in the Bio for Products project, working for BTG. He's been investigating the sustainability of the new products under development in the project. Nils is working or doing similar work in different projects and initiatives for IFEU, conducting LCA analysis of different products. He will share some of his insights. Kathryn will enlighten us on how we should turn data into words and messages to communicate credibly about the bioeconomy. But first of all, by way of introduction, we wanted to have a slightly wider overview of sustainability in the bioeconomy. And for this, I'm going to hand over to our first speaker, Matthias Stratmann. Matthias is Head of Sustainability at nova-Institut. After a bachelor's degree in engineering, he worked for 2 years in the project management department of an international company. Subsequently, he decided to focus on the topic of sustainability, completing a master's degree, and is currently finishing a PhD in life cycle and sustainability. The focus of his work at nova-Institut is LCA and other sustainability assessments, both in research projects as well as in services for private clients. With that, I give the floor to Matthias. Thank you very much.
Thank you, James. Warm welcome from my side. As said, my name is Matthias Stratmann, and I'm working for the Sustainability Department at the nova-Institut. It's a pleasure for me to be here today and to give you a short introduction into the broad topic of sustainability in the bioeconomy here at this series of Bio for Products webinars. That's how it goes. First, a short introduction of our institute. We are 35 scientists working in the field of bio and CO2-based economy. That means that we deal with bio-based chemicals and materials. We deal with biotech processes and CCU technology, and we currently develop expertise in chemical recycling. I do this with my department from a sustainability point of view, but I have colleagues that have an eye on policies, on markets, and on related technologies. This picture covers most processes we are working with. On the left-hand side, you see the CO2, which is taken up from the plants and then somehow converted into sugar, starch, fibers, etc. And then it can be processed further by various processes, from physical, chemical to biotech processes, and then end up in various different products. For us, this is also the definition of bioeconomy. And we always add the term CO2-based economy, that is basically skipping the plant and processing the CO2 directly, for instance, from the atmosphere through air capture technologies. We do that for many customers from all industrial sectors and in various research projects on European and German level. As said, my department is working on a sustainable bioeconomy, and we do this mainly by applying different methodologies like life cycle costing, like social impact assessment, footprinting analysis, and LCAs, life cycle assessment. And that brings us now a bit closer to today's topic. What is sustainability and what is sustainability in the bioeconomy? Sustainability is a broad topic. There are many definitions about that. My favorite one is the one from the report Our Common Future, which is also called the Brundtland Report and goes back to 1983. And it defines a sustainable development as a development that meets the needs of the present without compromising the ability of future generations to meet their own needs. But what does it mean in detail now? There are several concepts. The United Nations have developed the so-called Sustainable Development Goals. They shall serve as, now what they say, a blueprint to achieve a better and more sustainable future for all. And it starts, as you see here on the upper left-hand side, with poverty or no poverty and then zero hunger. Then goes through energy, economic growth and industry development until it ends there with climate action and life on land and below water. Another concept is split into 3 dimensions, or pillars or aspects, or however it is called. It's sometimes also referred to as a triple bottom line. Thereafter, sustainability has a social dimension, which includes nutrition, health, and then working conditions, for instance. It has an economic dimension, which covers jobs, prosperity, and economic wealth. And it has an environmental dimension, which covers all impacts on the natural environment. To really assess sustainability, all 3 aspects, dimensions have to be considered, but today's focus is on the environmental part of sustainability. But what is environmentally sustainable and how can this be assessed? As already said, there are various methodologies available. For instance, material flow analysis, footprinting, carbon footprint, water footprint, or there are also labels available to show sustainable feedstocks, etc. But we mostly rely on life cycle assessment, and that will also be a topic in the subsequent presentations. LCA, most of you will know that, is a methodology for assessing environmental impacts that are associated with all stages of the life cycle. That's the left-hand picture of a product, process, or service, and which gives up in the end such nice charts with a lot of information about the different environmental impacts of the different products. Now, I do not want to go too deep into the methodology itself. I want to use the remaining minutes to talk a bit about the general challenges in the assessment of sustainability of bio-based materials, which we face every day when applying LCA in bioeconomy. The first challenge is about different impacts, different impact categories. LCA normally assesses many different impact categories. Global warming potential is probably the most popular one, but there are also impacts on biodiversity, land use, and many others. What we see for bio-based products is that they often show less greenhouse gas emissions, which is global warming potential, and of course a lower abiotic depletion potential. But at the same time, the results in land use, water use, eutrophication, biodiversity are higher, always compared to fossil-based counterparts. That is, of course, due to the agricultural processes and the feedstock part, where water is used, where land is used, and where pesticides and herbicides are used to grow the plants. The challenge is here not so much the assessment itself, but it is the interpretation of what is now more sustainable. The second challenge is about economies of scale and the scale of the assessed processes. The bioeconomy is still an emerging field, and we assess many technologies on the low TRL level that are still under development or are only at early stages of commercial production. And what many of these products try to substitute are conventional fossil-based products like fuels or polymers or other materials. And if we have now a look onto the fuel and polymer production, we see running capacities on a much bigger scale. These plants are running for decades now and have seen many loops of optimization. Of course, we cannot compare lab-scale processes with industry processes, and we do that, of course, not because that wouldn't be meaningful, but it is a major challenge to scale up low TRL processes up to a level that is comparable with the current petrochemical sites. The third challenge I want to mention is about future scenarios. And yeah, it is just because technology is developed, of course, today, but it is then used for future decades. And that's why it is important to take the future circumstances and conditions also into account in life cycle assessment and other assessments as well. For instance, changing energy supply, agricultural efficiency, or future mining activities. And I would like to give you now a short insight of what we expect there in future developments. For the bio-based products, we expect a higher yield and less pesticides. mainly due to digitalization efforts like precision farming. And we think and see that the energy sector will switch to renewable sources. That means that even more energy intensive processes can work with only a few environmental impacts. On the other side, the fossil-based products as a normal counterpart for the bio-based products. There we think that the mining of reserves for metals, but also oils and gases, becomes more expensive in monetary and environmental terms, just because the good mines with the high metal content, for instance, will become lower, or the metal contents become lower, and there is the efforts will rise to get the metals, oil, gases out of the earth. And the second point is about the credits for burning the fossil-based products. That is now a bit into LCA methodology, but only a little bit, and I try to keep that short. But when we have a look on the end of life phase of a plastic shopping bag, this plastic bag will be certainly incinerated. In LCA, the plastic bag gets a credit because the heat generation of this incineration substitutes an alternative heat generation, which would be necessary otherwise. And as this generation comes today mainly from fossil sources, the credits are quite big. As soon as now the energy and heat generation are based on renewable energies, which will be in the future case, the incineration of the plastic bag substitutes only those renewable energies, and the credits will be less, and that will be less favorable for the fossil-based or the plastic bag. In general, we think that the future scenarios look more favorable for the bio-based materials and less favorable for the fossil-based products. Looking into the future is always a challenge, but we see it really necessary for bio-based products and technologies to get a fair comparison with fossil-based products. What is the resume out of this? We think that sustainability assessment in the bioeconomy is challenging, at the moment sometimes unfair in comparison with fossil counterparts. But a good sustainability assessment is absolutely necessary to decide where to go and which pathways to follow. And I guess my subsequent speakers will give you now some good examples for this. I hope so. In the end, I would like just to invite you to our Bio-Based Materials Conference, which will take place this year online and in May. And I like to thank you for your kind attention and will be open for all questions from your side. Thank you very much.
Thank you very much, Matthias. That was excellent. I've got a lot of questions here, and we will answer or attempt to answer a couple now. I will put them to you. Regarding the results and impact for land use, biodiversity, eutrophication, water use that you say is worse for bio-based products compared to fossil-based products, could you expand on this a bit, or to what extent would you say this is linked to the type of feedstocks that are used?
That is definitely linked to the type of feedstocks. That varies for each feedstock, but there's a general trend that if you have always, or at least if you do not have bio waste, but if you have this first generation feedstocks or an allocation to the second generation feedstocks, you have this agricultural part in which gives more impacts in the end. than the fossil-based processing. And this can be seen in most of the LCA results for bio-based materials.
Okay, we'll just go through one more question. Question about movement of biomass, let's say, and the carbon impact, for example, of moving biomass from Asia to Europe. The questioner asks whether sea freight should have a lower impact than road transport, for example.
What we normally see is that sea transport has only minor fractions of the overall results. Road transport is sometimes an issue, air transport is always an issue, but the sea transport is usually not a big issue.
Okay, well, thank you very much, Matthias. I think we'll leave it there for now. If people have more questions for Matthias, like I said, we'll have a discussion period at the end, so we'll endeavour to answer those. But for now, we'll move on to the next speaker. So thank you very much. So our second speaker is Jurjen Spekreijse. Jurjen is a consultant at BTG Biomass Technology Group, who are coordinating partner of the Bioproducts project. Jurjen obtained his PhD in bio-based chemistry from Wageningen University and joined BTG after completing a postdoc at Chalmers University. At BTG, he is responsible for sustainability topics such as life cycle assessments, as well as other questions related to bio-based chemicals and materials. Jurjen, over to you. Thank you.
Thank you very much, James, for your nice introduction. As James mentioned at the beginning of this webinar, I will indeed go a little bit more into depth, specifically on the bioproducts route. So answering the question, what is the sustainability of bio-based materials from pyrolysis oil? But before I go into more detail there, I would like to introduce a little bit more about BTG, Biomass Technology Group. We're a company in the Netherlands. We have two sister companies, BTG BTL and BTG Next. And BTG itself exists out of two units. We have an RTD department, which does all sorts of technology development based on biomass conversion, pyrolysis oil and pyrolysis oil applications. And we have a consultancy department where we do consultancy work on all topics related to biomass, bioenergy, sustainable energy, also bio-based chemicals. So a personal example I'm showing here is a report presented last year on the insights into the European market for bio-based chemicals that we produced together with the GRC. So then I'd like to briefly go back to bioproducts and introduce the value chain that we look at into bioproducts. I will not go into full detail. If you want to know more technical details, I would like to refer you to the previous webinars. But for now, to briefly go through, we start with some bioresources, biomass on the left, so 4 different types of biomass that were investigated by CAPAX. Then there's a processing step, a pyrolysis, and then a fractionation into lignin and sugars. This process is called a thermochemical fractionation, and this is done by BTG RTD. The lignin is taken by Hexion to produce PF foams and PF resins, and the sugar fraction is then taken by Foreco and by TFC to produce wood preservatives and molding resins. Finally, coordination is done by BTG, business feasibility by Evotech, and communication dissemination by Greenovates, which includes the webinar you're part of now. Some details on bioproducts. The project lasts until the end of this year. And the aim of the project is to move this value chain from about TRL 4 to TRL 6 to 7. And with TRL 6, 7, we mean the design and construction of a pyrolysis oil fractionation plant. So it's currently in operation at the BTG facility, and it has an input capacity of about 3 tons a day. We have some fossil replacement targets, so we're trying to replace the fossil content of the products. For the resin, we would try to replace the fossil parts by about 30 to 65%. And for the creosote, so this is a material used in wood modification, we aim to fully replace, so 100% 100% replacement of the fossil parts. And then finally, of course, we do a techno-economic evaluation and also the environmental assessment. And this environmental assessment, this is the work of BTG Consultancy in this project. And this is also the work that I'd like to present to you now. So the main question that we have is, how green is actually our value chain? Is it as green as we hope it is, or is it maybe less green, or maybe it's even greener than we think? So how do we really put a number on how sustainable is our value chain? And of course, to no surprise to you, this is of course done by life cycle assessment. The nice thing about using life cycle assessment to answer this question is that you determine all the environmental impacts over the entire value chain. So the words all and entire are crucial in this sentence. This is to prevent burden shifting, or what's more commonly known as greenwashing. And how this works, I will try to briefly explain. So let's say you have a product 1, which is product B. It's made from A, and this process produces a lot of CO2. You propose to replace it with a product 2, so you make the same type of product B, and the process produces much less CO2. So then it looks very nice and very good for the environment. However, if you don't look at all the environmental impacts, you may miss that maybe there's a different type of impact happening in your process. So that's why it's important to look at all the environmental impacts. The next, the entire value chain, we can explain it using the same system. So you have again the 2 products, but maybe there's a second step. So for example, end of life, which is much more polluting for the replacing product, therefore not fully assessing the environmental impacts. So that's why it's important to look at all the environmental impacts over the entire value chain. And this is what LCA is well equipped to do. So how does it work in LCA? I will briefly discuss a little bit how this works in practice. So you follow this scheme, which is from the ISO 1440 norm, where you start on the top left to define your goal and scope. So you look at your process, you ask what are the questions that we want to answer, and you also look at how does the process work, what are all the individual process steps. The next step is the life cycle inventory. In this step, you look at each process step and you look at what are all the inputs and the outputs, the mass and energy balances, and all the emissions of each of these process steps that you identified. And then the third step is the life cycle impact assessment. In this step, you look at all these inputs and outputs that you quantified in the life cycle inventory, and then you look at what is the environmental impact of each of these mass flows. And then finally, there's an important interpretation step. What do these results mean? Do uncertainty analysis, comparing different products, etc. There are 2 comments I would like to make. Biofuel products is a process in development, and as Matthias said in his previous presentation, there's of course a problem when you compare a process in development and the current fossil optimized processes. So we need to make some assumptions here, and we try to make the assumption that this process is performed at a large scale and how that then compares to the fossil processes. The focus in the project is on greenhouse gases. However, we of course keep an eye on burning shifts. So we look at all the impacts to make sure we don't have any greenwashing happening. Some technical details. I know there are some people in the audience that are really knowledgeable about LCAs. So we did a micro-level decision support LCA using attribution modeling. We followed the relevant ISO norms. We use CIMA-Pro as our software package using EcoInvent as the background database. And then finally, Recipe 2016 is our calculation method. And this is the calculation method that is presented here on the screen. On the left, in gray, you see all the midpoint impact categories. And these are all the environmental impacts that we determined in this project. So going from particulate method, ozone formation, ionizing radiation, etc. So these are all the impacts that we quantified. Then these impacts are sort of combined and calculated into 3 final impacts. These are the ones that you see on the right. So damage to human health, damage to ecosystems, and damage to resource availability. Then before I go into the LCA results, I want to take you also through the value chain that we're actually looking at. So the first step in the LCA is always to look at what is your value chain, what are all the individual processes. I will use the wood modification as the example, and at the end I will show very briefly the results from the other processes. So the wood modification, it starts on the top left with harvesting the biomass. Then there's the pyrolysis and fractionation step, which is done at BTG. Then at Foreco, they have a wood modification process. Of course, you need here a wooden pole, which comes from a production forest. They make the product fauna wood, which is a new product developed in biofuel products by Foreco. And this product, we assume that at the end of life, it will be incinerated. Then we want to compare this to a fossil product. So we compare it to creosotes. And it's important here that we also look then at the entire value chain of creosotes and not only the creosote treated wooden poles. So then I'll jump immediately into the results. This is one example of the 4 different products, and we look at wood modification again. The functional unit is what is the impact of 1 cubic meter of wooden poles for every year that it's standing. You see in the graph the 3 different endpoint scores. So this is damage to human health, damage to ecosystems, and damage to resource availability. And the first thing you notice is that for human health, the fossil-based route, so this is the creosote route, has a very large impact, especially compared to the very small impact of the bio-based pyrolysis oil route. I will go into more detail into that one on the next slide. For the ecosystems, the impact was already relatively small. It seems to be reduced a little bit, and a further reduction seems to be challenging since a large part of the damage to ecosystems actually comes from the wooden pole itself. So you will always need a wooden pole if you want to do wood modification on a wooden pole. Finally, the resources, the impact was already quite small since creosotes are produced from a side product of the fossil value chain, and it's even further diminished when you use bio-based alternatives. Then, as promised, a more detailed look into the damage to human health. This is expressed in disability adjusted life years, or DALYs. The first thing you might notice is that the bio-based route actually has a negative impact. And this is also related to what Matthias said at the incineration at the end of life, that you're getting credits when you're generating energy from the incineration at the end of life. So that's why you get some negative impact there. But the most important picture I want to show is that you see 3 environmental impacts that are significantly reduced. So first of all, global warming is significantly reduced, which is expected. Next is the fine particulate matter formation. And this is mostly from the production of creosote. So in the production of creosote, in this process, there's a lot of fine particulate matter formed. And this is the part that you're preventing when you produce the bio-based alternative. And then finally, there's the human toxicity. Creosote is a very toxic compound. So when you use this on wood modification during the lifetime, so during the use phase, you actually have a lot of human toxicity. So it's a nice example where you see that not only should you look at the different impacts, so not only global warming, but also the other impacts to get the full picture, but also the impacts are different when you look at the entire value chain. So we also need to look at the production where you save the fine particulate matter formation, but also the use phase where you reduce the human toxicity impacts. Then we also performed the uncertainty analysis just to ensure that the results that we have due to using a process that is still at lower TRL, what is our uncertainty and are these results significant? We did Monte Carlo calculation, so 10,000 calculations, and then the arrow bars I present here, they show the 95% confidence interval. And as you can see, 2 out of the 3 impacts, they show significant reduction, so damage to human health and damage to resources. For the ecosystems, there seems to be a reduction, but there's an overlap in the 95% confidence interval. And again, this impact is mostly related to the wooden pole itself. To conclude the other LCAs, I will not go through all of them in full detail, but here's an overview of the greenhouse gas reduction, which was the main topic of the LCA. So all the greenhouse reductions are significant. So we have a reduction of 70 to 90%, depending on the final product. So this looks very promising. And also to make sure we don't have any burden shifting. So there's an overall reduction of the environmental impact of all the value chains. And that brings me to the end of my presentation. I'd like to thank you for your attention.
Thank you very much, Jurjen. Very good. So as promised, we'll put to you a couple of questions. The first one relates to your assumption about incineration at the end of life. Is it not possible for either the waste or the product to be rather reused in a circular process? So is that possible, and how would you see that impacting the LCA result?
Yeah, that's indeed an interesting question. We also looked at a little bit ourselves within the project. We're still developing this process, so it's not fully optimized yet. But the nice idea, of course, is that at the end you have a modified wood, and since you can use wood to make pyrolysis oil, you could make a perfect loop feeding back your modified wood into the pyrolysis factory. We did not calculate yet how this would impact the results, since we don't have any full data yet on how pyrolysis behaves on this modified wood. But I think, especially for circularity reasons, it's an interesting way to go to.
Thank you. A question about methodology. Could you tell something more about the Monte Carlo modeling of the production?
Yes. So the Monte Carlo approach, it's what you do is, I explained a little bit on how the LCA works, so that you have for every, let's say every process step, you have inputs and outputs, so you determine all the mass flows. What you do is you assign an uncertainty to each of these inputs. So you say, how certain am I of this result? Like how much CO2 is produced in a certain step, for example. You attach sort of a standard distribution to each of these values. Then the Monte Carlo approach, what it does is it calculates the same process again, changing all these values within this normal distribution of each of these values. And then doing this plan enough times, so in our case we chose 10,000 times. If you do this enough, you will get a standard distribution of your results, and that I presented in the 95% confidence interval.
Okay, I hope that answered the questions. Yeah, with that we are going to move on. So thank you very much, Jurjen.
Okay, thank you very much.
We'll invite you back for the panel at the end, but for now you can have a break. So I will now introduce our next speaker, who is Nils Rettenmaier. Nils is a senior scientist and project leader at IFEU, the Institute for Energy and Environmental Research, Heidelberg. Based at IFEU's Department of Food and Biobased Systems since 2006, his main working fields are life cycle assessments of food and non-food biomass products, biomass resource assessments, and sustainability criteria for biomass. Nils, the floor is yours. Thank you.
Thank you very much, James, for this kind introduction and also for inviting me to participate in this webinar. Ladies and gentlemen, I'd like to present to you some selected examples and lessons learned from LCAs on bio-based products. First of all, a few words on IFEU, which is the Institute for Energy and Environmental Research in Heidelberg, Germany, founded more than 40 years ago. We are an independent organization organized as a private non-profit company, and currently we are about 80 staff. We perform research and consultancy in all fields of environment, and we are often using life cycle assessment for that. I'm based in the Department of Biomass and Food, and here we do many life cycle assessments for all kind of biomass applications, for fuels, energy, biorefinery systems, bio-based materials, and also for food products. We also perform biomass potential assessments. We are involved in development of future scenarios. And we also have moved beyond LCA towards the so-called integrated lifecycle sustainability assessment, where we combine different methodologies to get an overall result regarding sustainability. We have a long track record in life cycle assessment. Almost 30 years ago, my colleague Guido Reinhardt performed the first full life cycle assessment on biodiesel from rapeseed in Europe. And we have continued to work with this methodology since the early 1990s. We have performed these kinds of studies for all kinds of biomass inputs, wood, fiber crops, energy crops, and so on, even algae. So we have a huge repository of studies, which you can also access on our website. Currently, we are involved in a number of EU-funded projects on bio-based products, just to show you a couple of them. And as you can see in the rightmost column, lots of different bio-based products are being addressed in these projects, from oleochemicals through membranes, biopolymers, fluoropolymers, bioresins, etc., etc. The outline of my talk is relatively brief, as I only have a few minutes. My previous speakers have already touched upon LCA methodology, so I'll jump quickly through that, then present some examples, and then summarize the lessons learned and conclusions. As has been mentioned before, LCA has been standardized in the 1990s already. Two ISO standards, 14040 and 14044, apply. And this has been stressed by Jurjen already. LCA addresses all environmental impacts of any product that could be a good or a service throughout the entire life cycle. So a cradle-to-grave approach. As such, the methodology is only a broad framework, since it must be applicable to dozens of different research questions, and thus also leaves the LCA practitioner with some degrees of freedom to decide a couple of issues. In the recent years, a specific standard for LCAs on bio-based products has been developed at European level, the CEN 16760 standard, which has been published in 2015. And this is especially focusing on aspects that are very relevant for bio-based products. It is actually based on the ISO standards 14040 and 44 and details a couple of issues that are very relevant for bio-based products. Now, to my selected examples, I have chosen two. One comes from a study that we have conducted a couple of years ago already. It was funded by the German Federal Environment Agency. And in this study, we have looked into a number of selected case studies, which you can see at the bottom of this slide. We have performed so-called screening LCAs based on the ISO standards. We have looked into 9 midpoint impact categories. For the lifecycle impact assessment, we have applied the CML methodology. We have done so-called comparative assessments, which means that we have compared the bio-based product to a conventional, usually fossil-based product, and we have normalized the impact to EU inhabitant equivalents. The second example comes from an EU-funded project, which was finished in summer last year. The topic of this project was specialty oleochemicals from 2 oil crops that can be grown in Europe, which are called camelina and crambe. And the idea was to substitute tropical oils such as palm kernel oil, coconut oil, and castor oil by domestically growing camelina and crambe. In this LCA, we have also based ourselves on the ISO standards. We have looked into 10 midpoint impact categories, and in this case, we have used the Recipe 2008 impact assessment methodology. Plus, we have introduced 2 new impact categories, which we have defined ourselves: phosphate footprint and land use footprint. You can find more publication on those on our website. It was a full consequential modeling. Also here we compared the bio-based camelina and Krambe value chains to, in this case, it was a combination of bio-based and fossil-based conventional products. And also here we have applied a normalization to EU inhabitant equivalents. This graph on the left-hand side shows you a typical pattern. You're not supposed to read all the small text, but as you can see, for 2 products on the top and on the bottom, we always see for all these products both environmental advantages, bars that are pointing towards the left, and also environmental disadvantages, that are those bars that are pointing towards the right, if you compare the bio-based product to a conventional equivalent. And this pattern is already well known from many life cycle assessments for bioenergy carriers and biofuels. This is a similar graph from the Cosmos project on the oleochemicals. Also here we have looked into 2 different crops. On the top it's camelina and the bottom it's Krambe. And as you can see also here, there's a certain pattern, advantages for the bio-based value chain pointing towards the left and disadvantages pointing towards the right. And in this case, the bars show ranges for the results for a number of sub-scenarios. You can find these graphs and all the explanations in the corresponding report on our website. If we jump back to the 6 case studies, it is important to bear in mind that it is almost impossible to determine one common functional unit for all bio-based products, which is much easier when you look into bioenergy and biofuels, where you usually take 1 megajoule of fuel as the common functional unit. And the table on the left-hand side shows you a number of functional units which we needed to choose for the 6 case studies. So in each case, we have a different functional unit. However, it is still possible to compare the environmental performance of different products if you convert the results to a uniform reference unit. For example, for dedicated biomass, you can convert the results to 1 hectare of land, or for bio-based residues, you could also look into 1 ton of dry matter input, for example, as a reference unit. What is also important, and Jurjen has mentioned that already, is that especially the end of life stage is very important for the LCA, and specific settings are needed here for bio-based products, and these are much more complex than for bioenergy carriers, which are essentially incinerated at the end of their life. Regarding the processes that determine the results the most, you can't find a rule here either. It is clear that this depends on the respective bio-based product and on the impact categories considered. On the left-hand side, you can see 2 graphs on top of each other. Above is global warming potential, and below is the acidification potential. And just by looking at the different colors, you can see that different processes or life cycle stages have a different impact in the upper panel as compared to the lower panel. You can see more bluish colors in the lower one and more reddish colors in the upper panel. And that means that certain life cycle stages or processes are having a different impact in those stages. Sometimes it's the production of the biomass. Sometimes it's the expenses in terms of energy and materials used for the bio-based product. It could also be the credit for the conventional reference product, use differences in the use phase and in the type of co-product use, and as already mentioned, the end of life. This is the same thing from the Cosmos project. Here you can see different environmental impacts, ranging from non-renewable energy use to land use footprint. And the color of the bar elements shows you different processes or life cycle stages. And as you can see, for example, there's a yellow-orange one, which is very prominent in the freshwater eutrophication. And these are the field emissions from the agriculture. But this orange bar, for example, doesn't show up in the phosphate footprint or in the land use footprint. So to sum up what I've been running through with high speed, what can we learn regarding LCAs for bio-based products? First of all, I would like to underline that LCA is the most suitable and recognized instrument for quantifying the environmental impacts of bio-based products. Also, as Jurjen has said, it is not sufficient to look into one impact category, such as global warming potential or carbon footprint only. You need to address all the environmental impacts. And a special focus should be put on local environmental impacts, such as impacts on biodiversity. And it could also be done by a supplementary life cycle environmental impact assessment. It is not permitted to generalize results. So if you have a result for one bio-based product, you cannot transfer the results to other bio-based products, which are made from the same raw material, for example, because the results may vary considerably. LCAs for bio-based products can hardly be standardized. I've mentioned the need to define a specific functional unit for each of the studies. And this is in contrast to the LCAs for bioenergy. And moreover, use and end-of-life phases can be very different for the bio-based products. So for this reason, we strongly discourage so-called cradle-to-gate balances and strongly advocate to go for the full life cycle cradle-to-grave. To conclude, I'd like to say that bio-based products are not environmentally friendly per se or sustainable per se, just because biomass is a renewable resource. However, if you compare bio-based products to bioenergy, for example, you can see that the results are more or less comparable. There are examples where bio-based products clearly outperform bioenergy carriers. But from a security of supply perspective, it would make sense to steer the biomass more towards the material use in the future than for the energy use, and to emphasize the role of biomass as a renewable carbon source. However, it is expected that the already prevailing competition for land and biomass will increase with the expansion of the industrial use of biomass, and therefore I think that mandatory sustainability criteria for biomass should be applied irrespective of its later use, be it for energy, bio-based products, or food and feed. And with that, I'd like to thank you for your attention.
We would like to thank you, Nils. Thank you very much. It was really interesting. Yeah, we have lots of questions. We'll just go through a couple quickly. First one, can you explain the impact categories that you presented? How do they help?
Well, there are 14 different environmental impact categories at midpoint, which have been defined in the so-called ILCD handbook, which is a reference manual how to perform LCAs. The most prominent environmental impact category is certainly global warming potential, sometimes also referred to as a carbon footprint. Others are acidification of terrestrial ecosystems or nutrient inputs into surface waters, that is called eutrophication. We have impacts related to the use of land, for example, on biodiversity. The fact that we are growing crops has environmental impacts, and these are summarized or categorized in a number of environmental impact categories.
Thank you. Which to choose? Question for Nils. Have you ever tried assessing biotic resource depletion of bio-based products? Are there existing methodologies? If not, should there be any?
As I mentioned in my presentation, we are looking very much into the land use footprint of different value chains. And we have newly brought up a methodology which is based on the Hammurabi concept, and you can find a corresponding publication on our website.
Okay, thank you so much, Nils. We're going to move on, but as advertised, we will bring you back again at the end to answer any final questions. So thank you very much. So finally, last but certainly not least, I would like to introduce Kathryn Sheridan. Driven by her strong personal belief that organizations need to communicate better on sustainability, Kathryn set up Sustainability Consult in 2008. Today, Kathryn guides the firm's business relationships and advises companies on strategy and engagement. Over to Kathryn to tell us more. Thank you, Kathryn.
Thank you, James, for the introduction. I'm here to talk about not LCA, but how to communicate credibly in the bioeconomy and how LCA fits within that. So I'm based in Brussels. I'm specialized in bioeconomy and sustainability communications, and I serve as a credibility consultant, also a speaker, writer, and a business and leadership mentor. So Sustainability Consult, we've been around since 2008.
Sorry, Kathryn. Just to come in, we can't see your screen at the moment.
Hold on.
That's it.
Okay.
Yeah, we're there now. Thanks very much.
So I just keep going?
Yes, yeah, sorry to interrupt. It's perfect now.
Thank you. So Sustainability Consult was founded in 2008, and we are specialized in communications and media on the bioeconomy and sustainability. We also work across the biotech sector. These are some of our projects, past and present, and we are the communications partner on the EU flagship project Biosco, and that's a second-generation ethanol plant which will be built in Slovenia. So we work on sustainability, credibility, and bioeconomy. And so how does this all link in to LCA? Well, I always recommend to clients that they have an LCA. I feel that it's really important, but my main message today, if you only take away one thing, is that LCA itself is not a communications tool. So what do I really mean by that? LCA can be inaccessible, it can be highly scientific, it's extremely interesting, as we've seen from the earlier speakers, but in itself, it's not a communications tool. LCA needs to be interpreted, and there are very often arguments about the methodology and the inputs. It's not the thing that's going to make a product a success. Now, in EU projects and policy, we hear a lot about innovation and the valley of death. It's not LCA that's going to make or break a product. So we have the research and innovation and the market, and in between that, we have this vast area of commercialization. And that is actually where most bio-based companies fail, and that has nothing to do with their LCA. So who decides basically which products will be a success? Well, decision making is with the stakeholders. That includes policymakers, consumers, and brands and retailers. And stakeholders mostly don't understand your LCA. Mostly, they're not scientists. So my advice is don't assume that the brands or the end customer cares about your LCA. You need to take the LCA and draw the benefits from it. Draw the benefits about the product and show how your material can help the company or the retailer or the brand to meet their own sustainability goals. But it is important to have an LCA. I do believe LCA matters, although of course in the early stages it's not so easy for a company to do an LCA. But LCA does provide the evidence to back up the claims, and it helps us to reduce or hopefully to avoid greenwashing. LCA adds to the transparency of the company and builds credibility. And what's really important to me is that credibility builds trust. That's why much of the work that I do today is around credibility consulting and reviewing messages and strategy and communications to bring different stakeholder viewpoints and make sure that the claims that companies are making and the things that companies are saying are indeed credible. So how can we use LCA? Well, of course, it's useful in technical discussions, scientist to scientist or technical developer to technical developer. And we can use it for benchmarking. And that's an important point. We should never claim that a product is green or sustainable or has a low carbon footprint. It should always be in comparison, and the LCA gives us that data. It should always be better than something else, a lower carbon footprint than another product, and that increases the credibility of the claims. So should I really bother with an LCA? It's complicated, it takes loads of time, and it's expensive. Well, I do find it problematic if you don't have life cycle data, because you can't benchmark against the alternatives. And in terms of alternatives, you need to think about a fossil alternative, but also if you're working on plastics, recycled fossil is also another option that many companies are taking, as well as other bio-based materials. And there might also be a range of methods and processes to arrive at that same bio-based material. What we've learned, I think, the hard way, and I work a lot with companies in the bio-based industries, we've learned the hard way that sustainability alone is not enough. It can't be the only benefit. And what I call the holy trinity are the three things that we always need to have with a bio-based material. The first is cost, and that's automatically tricky. And then performance. It needs to perform as well, if not better, than the incumbent product. And then the sustainability criteria, the sustainability attributes are the icing on the cake. I want to give you a real life example. This is a toilet roll product called the Good Roll. So I'm going to run it through my holy trinity and see how it scores. Well, firstly, cost. This product was actually a little bit more expensive than the toilet roll in the supermarket, but bearing in mind that we are at the moment in lockdown, I was not going to the supermarket to buy a toilet roll, and so this actually seemed quite reasonable to me in terms of cost. The performance was absolutely fine. The rolls are bigger than the average roll, so to me it scores on performance, and sustainability is a real win. It's 100% recycled, and they build toilets in areas where toilets are needed. So for me, this is a good product. And I'd like to just draw attention to the fact that sustainability, as mentioned in the beginning, is about more than environment. So it also includes the social dimension. And without taking into account social dimensions, there cannot be sustainability. We can't have environmental justice without social justice. And this is a much bigger question. It's beyond the scope of our discussions today, but we need to look at the supply chain and the social impacts. And I'm certainly not an expert on this, but when I started looking into it, I saw that social LCA is also a thing. So that may be interesting to look into. In terms of messaging, if the LCA is not going to sell the product, then what is? Well, selling is all about emotion. The customer wants to feel good about their decision, about their purchase. We respond to hope, not fear. We respond to love, not hate. And we want positivity. And the doom and gloom messages about climate change that we've all grown up with, they haven't really worked. We've been in this situation, and I've been in this business for a long time. Doom and gloom isn't working. So we do need to appeal to people's better nature with a positive message. And what gives me a lot of hope is now I'm seeing more and more about regenerative solutions. So it's not just about doing less bad, it's also about doing more good. And what doesn't work? Well, you've seen that the discussions around LCA can be quite technical. They can be too scientific. And so that's fine for a discussion with someone on that same level, but it doesn't work necessarily for the end consumer or the marketing people. If it is seen as a naive message, like the claims do not stand up, they don't feel credible, then that's not going to work. And the consumer is more and more aware these days. There is so much more transparency. And so any message which is basically lacking in credibility is not going to work. And we will see that increase and increase in the coming years. I want to throw a bit of a spanner into the works maybe and just put this in some context. Basically, nothing is sustainable. You know, we are exploiting so much the limits of our planet, and as a species, we are just basically exploiting and destroying the planet. So really, nothing is sustainable. We can only try to do better and to be more sustainable. So in conclusion, I do think that LCA is very important. It's part of that background information on the product, and it backs up the claims to avoid or reduce greenwashing, but it certainly shouldn't be the main message for communications and marketing. Thank you.
Thank you, Kathryn. Very good. So we'll direct a couple of questions straight at you to start with.
Sure.
So the first one is, how big a problem do you think greenwashing or misinformation is for the bio-based industries?
I think it's a problem everywhere, and it's not always intentional. I must say that very often people have the best of intentions about the product. They really believe in the product that they have, but they may not have all the data, or they may not have a good enough experience at interpreting the data. And so greenwashing claims can come about. And it's also something that I see quite a lot is companies using an agency, for example, to do social media. But if it's not an agency that's specialized in social media and sustainability or communicating on sustainability, we see a lot of messages and a lot of sponsored posts, especially, which I pull them apart because they're just not credible. So I don't think that the bio-based industries are necessarily exempt from that. I do think that we are quite aware about sustainability in the industry, but certainly we have to be as careful as any other industry, as any other sector.
Very good. And then secondly, how do you communicate a clear picture if you get an LCA result, for example, and it has some clear disadvantages, for example? How do you go about communicating that?
Well, communication always has to be done honestly, and so you will try to identify the advantages of the LCA, but you have to also refer to the negatives. And that's the thing, people are not very comfortable with having a very transparent, honest form of communication, but actually that's the only way to go.
Great. I think I would like to invite all the other speakers in at this point, and we can have a little discussion. So I would invite all attendees to keep putting your questions in the question box. Maybe just a slight curveball. I just want to first ask the speakers, do you have questions for each other? You're the ones who don't have the opportunity to ask at the moment. So is there any burning question you have for one of the other speakers? Yeah, Nils, looks like you're...
I don't have a question. I just would like to underline what Kathryn has just said. It's very important to do no cherry picking in the communication and to communicate as transparently as possible. There are already a few examples where companies, or let's say the communication agencies, have chosen only the positive aspects and communicated those, and they were even sued in court that they have not conveyed the full picture. And there's also an element in LCA, if you want to use it for marketing, you are forced to do a so-called critical review by external experts, which come and visit you at your office and sit in front of your computer to really check the calculations that you have done to make sure that any claims that you make are fully substantiated, because in case the new product is much better than the old product, it could have a market distorting effect, and you must be very sure that these calculations are absolutely correct.
I think that's a really important point. And I mean, I think the challenge for marketing people in companies, imagine that you're, in a food company or a consumer goods company, the size of the pack somewhat limits the information that you can share. And that's then the time to have, websites giving additional information and backing up the story.
Very good. Okay, let's dive into these questions. I've got a lot popping up on my screen. So, where to begin? LCA is increasingly mentioned, referred to in EU regulation. How can we guarantee that policymakers can interpret LCA results correctly?
We can't.
How can we try?
What I think is we have two levels there. On EU level, we have, of course, the decision makers, where we can't make sure that they understand our results. We can communicate it better, and we can make perhaps use of endpoint indicators instead of 20 different results. But what we try to make sure, and I think also the IFEU Institute does the same, that we try to approach the specialists on EU level, where rules are made, standardization is done, perhaps in the GRC department in the European Commission, and we try to approach them and not so much the decision makers that are on a much higher level somewhere else, to get our ideas into that standardization.
I think it's also where you have to have transparency about the lobbying that goes on in Brussels and in the member state capitals. We can have all the data that we want, but if the messages being taken to policymakers are not based in facts and not credible, then unfortunately there's a limit to what we can influence.
All right. Okay, one on a little technical stuff. Question, which is the most promising chemical building block from the perspective of your techno-economic, but also the LCA perspective? Can you identify one and say, actually, this has had the best results?
If we look at just giving an example, it's a very difficult question to answer. Looking at only the biofuel products value chain, you could say, okay, this one, if you add up somehow all the environmental impacts, this one has the lower overall score. But I don't think that's a relevant question to answer in that way. I think you need, the different products have different applications, and they usually have different types of environmental impacts that are not easy to compare one-to-one. So I think a healthy mix of different bio-based products is required, and not just one overall winner, I would say.
Nils, yeah, please.
If I may add, I mean, we can see a certain pattern. There are building blocks, small building blocks, C1, C2, something like that. They have a low specific greenhouse gas saving, for example, but they are produced in large volumes. And there are specialty chemicals, on the other hand, which have a high greenhouse gas saving potential, but are produced in small volumes. So the question, which one contributes more to greenhouse gas savings, is not fully clear to be answered. I would also refrain from mentioning just one value chain as the winner.
And if I may, in terms of context, this also plays into the desire to have a silver bullet and not to actually address how we consume and the fact that we need to consume less and consume better. So there isn't one magic solution.
Well, that's a shame. No, okay. Next question. So here we're looking for some general rules of thumb of how actors in the value chain can improve the environmental performance of bio-based products. So are there some good practices which you see will lead to better LCA results, or which ones can you pick out to use as good examples? It's an open question, so don't all speak at once. Okay, Jurjen, you're giggling. You're going to have to answer something. You're going to have to say something.
Yeah, I think it's again a very challenging question because it really depends on what is the value chain you're looking at. Are you talking about a value chain with large transport distances, or are you talking about a value chain with high toxic compounds? So usually what I prefer is that you first do a quick sort of a screening LCA. So you check very roughly what does the value chain look like, what are the different impacts, where they come from, and then you can answer this question, okay, this particular step in your process chain has a very large impact, and then you can try to adjust it. But again, I don't think there's one silver bullet recommendation on this is what you should do to make it sustainable.
Okay, very good. So moving on from that, bless you, we have some questions about certification, for example, or labeling, or how do we then, if it's so difficult, these LCAs to compare one to another, potentially, how can we make this clear? Can we put numbers or some, the use of, for example, labels or certification to make this clearer to consumers, for example? Yeah.
In the CEN activities around bio-based products, also a standard on sustainability criteria for bio-based product has been published, and it mentions the areas or the themes that have to be addressed, among others, greenhouse gas emissions, but also biodiversity. It also includes the social and the economic dimensions of sustainability. And if people are interested, this could be used as a reference. But then these standards first need to be implemented by certifiers. And I know, for example, one certification system, ISCC Plus, which certifies biomass for bio-based products. And I think also RSB certifies biomass for bio-based products.
It's also quite confusing for consumers because there are so many eco labels on the market. There are hundreds of eco labels, and that does get really confusing. And some retailers even have created their own. So, you know, we do always need accountability, transparency, and credibility in any labeling schemes.
All right, I'll keep moving. We've got lots of questions here. Question about circularity and how this feeds into LCAs. How easy is it to take into account reuse and circular value chains within the current LCA methodologies?
It's a standard procedure to also include recycling steps in an LCA. That's not an issue, and sometimes it's very interesting to see the result, because if you recycle too often, you also need energy input for your recycling processes. There's a sort of point where recycling doesn't make sense anymore after a certain number of loops. But it is generally possible to address recycling in LCA.
Very good. Slightly provocative question here. Nobody's asking our fossil counterparts for LCA. I mean, can this be addressed? What to think and make of that, as the question puts it?
But I'd be interested to hear from the LCA scientists on the panel how they deal with that. I mean, how do we get the data for the fossil equivalents?
Fossil equivalents, they are very well researched. I mean, all the chains that are based on crude oil, for example, we have our own refinery model running at IFEU. There are commercial databases from which you can get data on current or past value chains in the fossil world. The question is more, how do we get future data for these value chains? Because sometimes our bio-based value chains are in an early stage of development and might only be on the market in 10 years time, for example. But how does the fossil world look like in 10 years time? And I know that EcoInvent, for example, is discussing issues like that at the moment. EcoInvent is one of the commercial databases from where you can get the LCA data.
Great. Okay. A methodological question. Should attributional or consequential LCA be preferred? Question mark.
I prefer attributional LCA, as consequential LCA might in theory be better, but yeah, cannot reach the intrinsic goals of consequential LCA. That's what I feel, to include all the market effects, feedback loops, and what is stated there. Yeah, can be for sure included a little bit, but not that comprehensive. And from my side, a consequential LCA will be less credible than the attributional one, and yeah, that's why we use the attributional approach.
I don't agree with the less credible. But the thing is, in the ILCD handbook, there's a clear framework how you shall decide based on the so-called decision context, whether you should apply attributional or consequential modeling. And depending on which situation you are in, you should apply either attributional or consequential. We at IFEU do a lot of consequential modeling. It's more challenging, but it's also fun.
Yeah, if I can add to that, I think I agree that both have a place. Consequential modeling is a bit more complex methodology. You usually need, well, like Neil said, it's more fun and more complex. But that, from the other side, it also means that it's usually more expensive, and also adds, it can add a lot more uncertainties. So it really depends on the type of product and the type of process you're looking at. And I fully agree with that. The current methodology, the standard methodology, how it's set up, you get directed whether either an attributional or a consequential LCA fits best to the question you are asking. So I think you really have to look at what are the questions that I want to answer in this LCA, and you follow the procedures that are currently in place.
And I can't resist jumping in and saying that this illustrates the complexity of LCA and the challenge of communicating on LCA.
Yeah, indeed. Okay, we have a questioner who's looking for some help. As a manufacturer, my raw material is a waste product of another agri product. How can I perform a full LCA if I can only assess the process that starts from my production plant? So maybe somebody who's looking for some help from one of you guys.
Yeah, if the product that this company uses as an input is really a waste product, which is get without extra costs, then there will no burdens be allocated to that waste. And then it would be just the process then of the company that would have to be assessed, but not the feedstock and agricultural part of that waste.
I suppose the others are in agreement. Okay, what else can we still do? We still have a few more minutes, so I'm going to go for a couple more questions. How about this one? Bio-based feedstock can have a positive impact on increasing biodiversity, for example, thinking of extra agricultural fields or biodiversity within planting programs in forest. Is this taken into account as a positive side effect within LCA?
If I look at the standard methodology, I don't think this is a standard case that you would take into account. However, if you look at every specific product, so every specific LCA you're looking at, you could take this into account, but you would have to set up the system yourself. So it shows the complexity of LCA, that you really have to be looking at what are the questions that you want to answer. And in this case, you want to know, does this specific agricultural setup that I have that is actually helping the biodiversity, what type of impact does it have? You would need to have a specific set of rules to implement it into the LCA. But I think that if you do an LCA on that production process, you will definitely have to find a way to implement that in the results.
Yes, there are possibilities to account for the fact that you are using, for example, a new crop that adds to the diversity at landscape level, that you're using less of the conventional crops and include new crops as well. That can be taken into account. And also you can compare, of course, different crops among each other in terms of biodiversity impact. So also the positive impacts can be stressed, yes.
Okay, now a big question that's probably been asked before, but it's always a good one. How useful is the term bio-based if you're talking about your products? Is this useful from a consumer or end user point of view in marketing? Are we using totally the wrong terminology? Should we just be talking about how sustainable something is, considering that bio-based doesn't always mean sustainable, as you've already mentioned today? Yeah, I'll just throw that out there.
And it's even worse. Bio-based is not a certain term which implies that the product is fully made of biomass. If you look into the European norms, it says that it's any product that is partly or wholly made from biomass. So even a very small share of biomass in a combined product, which is partly bio-based and partly fossil-based, can be called a bio-based product. And there have been huge discussions in the CEN arena whether one should introduce a certain threshold below which a certain product should not be called bio-based. And I think this is one of the aspects which adds to the possibilities of greenwashing, that there is no lower threshold.
Can I just say it's complicated? I mean, you have a risk of also a lot of confusion in Europe when bio in many languages, bio means organic. So it is confusing. I work a lot on plastics and bioplastics, and also the confusion there around bio-based, biodegradable, marine degradable. I mean, it's a minefield. And that's why, regardless of what terminology you use, you need to back up your claims with data, and you need to be honest and transparent about what you're selling. And I'm happy to hear that, you know, CEN is looking very seriously at these distinctions, because it is something that we need to address.
I think the term bio-based, it's a very useful term within science, so really a technical term. We want to get rid of all the fossil products to really keep the oil in the ground to prevent all these greenhouse gases, and switching to bio-based is a very useful tool. However, if you look at it from a consumer point of view, as mentioned already by the other panelists, it's a very confusing term and consumers don't really know what it is and what are the benefits. We also mentioned bio-based is not necessarily more sustainable. So I think it's a term that's useful in science, but maybe not as useful in communication. And within communication, you may have to refer to other tools that are, or other names that are more useful for consumers.
I think we also have to increase science education because there's such a lack of knowledge within the general public. I mean, people don't generally realize that plastics come from oil. So when you're starting at that level, it's quite a big hurdle that we have to cross as communicators.
What we try to say is now rather renewable carbon than bio-based products, as renewable carbon can come from biomass, but also from CCU technology or chemical recycling. And that's then another question, what makes more sense for the specific application.
Yeah, we've been having some reflections about bio-origin, but I mean, it is complicated and I don't think there is one, again, there is no one silver bullet magic solution. It is complicated.
Well, I think that's a really neat place to end the webinar. How sustainable is bio-based anyway? It's complicated. And for anybody who came looking for a yes or no answer, then they're going to leave disappointed, but that's the world we live in, I suppose. So I am going to close the webinar now. We're just run out of time. So I'd like to thank the four of you very much for joining us today and giving all of your insights. It was really excellent, I thought. So to our attendees, thank you also very much. I just want to point you towards the recordings of previous sessions of this series, which gives you a bit more of a technical insight into what we've done in the project. Should also say, if your questions were left unanswered, I'm sure the speakers would be happy to answer them bilaterally. I think their email addresses were included in most, if not all, of the presentations, and we'll make sure you have those so they remain at your disposal for further questioning to a certain degree. Anyway, so thank you very much. If you'd like to find out more about our Bio for Products project, then I invite you to visit the website, follow us on social media. The presentations will be made available, will be distributed along with the recording in case you missed anything. Thanks again to the presenters, to the attendees. That's all for today. Goodbye. Thank you. Stay safe.
Thank you, James.
Thank you.
Bye-bye.
Bye-bye.
Bye.